In this first lesson in fractions, we'll look at changing between mixed numbers and improper fractions. Before we do that, we'll have a quick reminder of what proper, improper fractions are and what mixed numbers are. So let's start off with proper fractions. Proper fractions are basically any fraction where the number at the top is smaller than the number at the bottom. So these are when you first learned about fractions, this is the sort of thing you probably would have seen first. For instance, 3/4, 2/3, things like that. So basically, the number at the top here is smaller than the number at the bottom. So improper fractions are basically the opposite of that. So for instance, the number at the top is larger than the number at the bottom. So 4/3, 8/7, fractions like that, where, as I said, top number is larger than bottom number, top larger than bottom. And lastly, we move on to mixed numbers, which is a mixture of a whole number and a proper fraction. So for instance, things like 2.5 or 3 5/6. So it has a whole number part and a fractional part, which is a proper fraction. So in a mixed number, we should never have an improper fraction as the fraction part. It must be a proper fraction for the fractional part. The first thing we'll do is we'll look at how we change from mixed numbers to improper fractions. So let's just choose a couple to demonstrate with. So we'll use like 4 2/3 and maybe 3 and let's say 1/4. And what we'll do is we'll draw 5 circles here and see if we can show how 4 2/3 can be changed into an improper fraction. Now, 4 2/3 here, the most important thing here is we're dealing in thirds. So what I'm going to do is take each of these circles, each one represents 1, and I'm going to split it into thirds. And then what I'm going to do is I'm going to start trying to shade in that 4 2/3. So we'll start with the 4. So that's 4, so that's 1 circle, 2, 3, and 4. So that's 4 full circles, so that represents my 4. And then I want 2 of the thirds in the final part to be shaded, so that's 2/3 there, and I'm obviously leaving this little bit blank here. Now what I can do then is I can count up the number of thirds that I have. So over at the other side, I'm going to write out of 3 because I'm dealing in thirds, and what we're going to do is count up how many thirds I've actually shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've shaded in there 14 thirds, which means 4 2/3 as a mixed number can be written as 14 thirds. So this is a mixed number converted into an improper fraction. Now, a couple of things here we need to note before we go on to a quicker way of doing this. One, the denominator hasn't changed. We started dealing in thirds and we're still dealing in thirds. And then how do I get this number here at the top, this 14? Well, I've got 3 in each circle, 3 sections, and I've got 4 full circles. So straight away, a good way of counting up this part here would simply be to say that this is 4 lots of 3, so 4 multiplied by 3. In the last section here, we have 2 shaded parts, so we would need to add them on, so plus 2. If I take what I've written here, 4 times 3 plus 2, that's where this 14 comes from. 4 times 3 is 12, add on 2 gives me the numerator there. So let's have a look at the next question and we'll do something similar. In the next question, we're dealing with 3 1/4. So the fraction part we're dealing with is at quarters. So first of all, I'm going to take these circles and split them into quarters. And again, what I'm going to do is I'm going to start to shade in that 3 1/4. So we'll start with the 3. I need to fill it in or shade in 3 full circles to represent my 3. And then the 1/4 part, I'm only going to shade in one of these little quarters down here. And I'm now asking myself, how many quarters do I have? So over at the right hand side here, I'm going to put out of 4 or quarters, and we're going to simply count through them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 quarters. So again, we can say that 3 1/4 can be written as 13 quarters. But what we need to do is obviously find a quicker way. So we look at the denominator, 4. It remains in 4. We started dealing with quarters, so we should still be dealing with quarters over here. And then how do we get this numerator? How do we get the top number? So again, following the same process, here we have 3 full circles, each with 4 sections. So this is 3 multiplied by 4. And then in this circle here, we only have 1 section, so we need to add that 1/4 in. And the 3 times 4 plus 1 gives us this 13 at the top. So in both cases, to get the numerator, the 14 and the 13 here, we do 4 multiplied by 3, add on the 2. To get the 13 here, it's 3 multiplied by 4, add on the 1. So we're going to now apply this to examples to do it a bit quicker. So looking at these two examples, 4.5 and 7 3/4, to get the new numerator, so the top number, we multiply the whole number by the denominator and then add the old numerator. So that means 4 multiplied by 2 plus 1. 4 times 2 is 8, plus 1 is 9. So this simply becomes 9 over 2. Again, you'll note the denominator here does not change. So 4 times 2 plus 1 gives us the new numerator, and denominator remains the same. We'll repeat that process again here. 7 multiplied by 4 is 28. Add on the 3, that gives us 31. So that's our new numerator. And the denominator doesn't change, so remains as 4. And that's a quick way to do it using a little algorithm there. We'll now look at the reverse case where we change from an improper fraction to a mixed number. And again, we'll just choose a couple of fractions to use as an example. So we'll use 9 over 2 and 11 over 4. And again, we'll just draw out some circles here. For the first example, 9 over 2, we're dealing in half. So the 2 at the bottom represents the fact we're dealing in half. So we're going to take these circles and we're going to split them into halves. We'll then look at the top section here, the 9. And that tells us we need to shade in here 9 of these halves. So we'll start to fill them in counting as we go. So that's 1, 2 halves, 3, 4, 5, 6, 7, 8 and 9 halves there. What we then have is we have here 4 as a whole number, so 4 full circles shaded. So we can maybe put in 4 as our whole number, and left over here you can see there's only 1 half here for the fractional part, so we can say that's 4.5, which means we can take 9 over 2 or 9 halves and we can rewrite it as a mixed number 4.5. If we want to look at how do we get from these numbers to these numbers here, again we can spot that the denominator here isn't changing. We start dealing in halves and we're still dealing in halves here. To get the numbers here, this 4, what I'm effectively doing is saying how many times does 2 go into 9? How many times can I make up a block of 2 given 9 pieces to start with? So that would be 9 divided by 2, which we know is 9 goes into 2 4 times, remainder 1. Now, the 4 times we can see is represented here with the 1, 2, 3, 4 full circles. This is this number here, and the remainder 1 is the one that's left over that we couldn't make another 2 from. So this is our 4.5. Basically 9 divided by 2 gives me 4, remainder 1, and the denominator doesn't change. We'll look at the same sort of example with the next one. We'll go through it a bit quicker. So here we have 11 quarters, and that means I want to split these circles here into quarters. And what we're going to start to do is shade in 11 quarters. So that's 1 quarter, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So from this, what we can see hopefully is if I go over to the other side here and write down, we're dealing in quarters, so the denominator is going to remain 4, and then we start to look at what we've got. So we've got 1, 2 full circles, so that's 2 is my whole number, and in the last circle here that we shaded, I only managed to get as far as shading 1, 2, 3 of those quarters, so that means I have 3 quarters left over. Again, going through a similar process to get these two here, what we're trying to do is see how many times 4 goes into 11, or how many groups of 4 I can make from 11. So that would be 11 divided by 4. Now 4 goes into 11 twice, that only makes 8 though, so I have a remainder of 3. And you can see here the 2, in other words 11 divided by 4 gives you 2, that's your 2 full circles and your whole number. And the remainder 3 is the 3 that are left over here that don't quite go to make a full 4, and that remainder is what's left at the top of the fraction there. So 11 divided by 4 is 2 remainder 3, so 2 remainder 3, and the denominator doesn't change. We'll now go on to apply that a little bit quicker just using an algorithm on the next slide. So quickly using a little algorithm here, the whole number is the quotient, which is the result of your division. The numerator will be the remainder, and the denominator doesn't change. So we'll go through that quickly and show you what all of that means. So first example here, 19 divided by 4. Well, we know 4 into 19 goes 4 times remainder 3. 4 4s are 16, that leaves us 3 left over. And I just need to put those numbers in the right place now. So my quotient here is 4, so that's my whole number, so I can put that in. And my remainder here is 3, so that's my new numerator, so it's going to go up at the top here. And as we know, the denominator doesn't change, so the denominator, we were dealing in quarters, we're still dealing in quarters here, so we can put that in. Look at example B. Again, we're going to be doing 6 into 25. 6 goes into 25 4 times, remainder 1. So again, the quotient, the 4 here, that's my whole number, so I'm going to put that in straight away, a large 4 here. And the remainder is 1. So that 1 is my new numerator, so it's going to go up here. Lastly, the denominator doesn't change, so we were dealing in sixths before, so that means we're still going to be dealing with sixths down here. And that's a quick way to change from an improper fraction to a mixed number.